Hello there, students. We are Group 1 of 12L, and today we are going to give you a brief overview of our game, Good Froyo, Great Froyo.
Physics is quite a difficult subject to learn, so usually this is because of the numerous equations, formulas, and understanding that you would have to take into consideration. Because of this, Group 1 has conceptualized an easy and entertaining way to learn about physics. Thus, the game Good Froyo, Great Froyo was made.
Through this game, you, the students, will be able to first and foremost test the game with its amenities such as the catapult and the game cards. Alongside this, you will be able to gain a further understanding on topics such as horizontal and vertical motions. And lastly, this game will also be able to serve as a real-life application of physics.
So, let's head to the materials needed for this game.
You will be needing two components for this game, the catapult and the board game itself. Let's start off with the catapult. You will be needing the following materials: popsicle sticks for the base, rubber bands for binding, and bottle cap for the launcher.
For the game board aspect, you will be needing the following materials: illustration board, hot glue, paper bowls, cards, and crumpled paper for the projectile.
Once you have built the board game and the catapult, let's start playing the game.
But before that, how do we play Good Froyo, Great Froyo?
You draw one or two cards from the deck of customer orders. Each card shows a customer order with a mix of strawberries, chocolates, and caramels.
Your job is to complete the order in 3 minutes using this catapult to shoot the ingredients into their matching cups. Ta-da!
So, if the card says 3 chocolates, you need to make it to the chocolate basket, and so on. Miss the timer, and it's game over.
Challenge your friends, race against the clock, and see who's the fastest. Ready to play? Let's go!
As per the tests performed, 3 different flavors were tried, each having 3 separate trials by themselves. These trials were then averaged so that the data may be computed and understood. The values found are as follows. Whilst providing valuable data, there is a noticeable lack of needed information. Thus, the data has been reorganized and the missing data has now been listed, showing the formulas necessary to solve. For further highlight, given values are in bold text. Now that the values have been well established and understood, we simply have to perform the calculations based on the equations given. Doing so ultimately results in our sets of values showing as such. Though there was little to work with enough problem solving and understanding, we are ultimately capable of finding the answers. By carefully examining known equations and concepts, we are able to create new equations to find values from the limited given data.
Thank you, Rustin and Kim, for that wonderful demonstration. So after playing the game, maybe you want to learn more about physics. Our group has prepared a set of questions that you can try answering in your free time.
So, why don't we try answering a question? How about question number 3? Is there an efficient in the maximum height and distance traveled in projectile motion? In what ways do they differ?
That's easy. There's definitely an effect in the maximum height and distance. By adjusting the angle as you launch the projectile with your catapult, so does the estimated maximum height and distance the object will travel.
So, your turn. Try answering this guide question too.
When playing this game, it is important to remember that you are limited to the materials that are given to you.
By using only these materials, the gameplay will be much easier and understandable to your liking.
If you're having a hard time answering the questions or doing the calculations, no problem. You can look into using the formulas in answering them.
That will be all, and have a fun time learning and playing.
The game-based physics experiment that our group created was definitely fun because by playing our game, not only we understood the physics concept behind it, but made us take part in the activity, made us visualize the concept, and making us understand it clearly.
I believe that our group did a great job in including game elements and interactivity in the experiment we created. It engages you in playing a fun game with friends while also providing you with a visual representation of an object in the projectile motion, which can help you have a clearer understanding of the different concepts in physics.
The game was expertly able to showcase a demonstration of projectile motion. As a result, it also elaborates on the concepts of vertical and horizontal motion, as projectile motion itself is merely a combination and application of the 2 topics mentioned. Though it may lack in other main topics, such as vectors and free body diagrams, it is ultimately still capable of assisting in one's learning and understanding of physics as a concept.
I find the game-based physics experiment to be very engaging rather than traditional learning methods. It made traditional learning an easier way of understanding and a fun, interactive activity which boosts my interest in the subject.
Through the experience of what we did as Group 1, the strength of one of the strengths is how fun and easy to understand of the concept of the game, and not only just the game, but physics itself. Though the weakness of the design are not actually from the game itself, it's by how the current of the wind resistant and how strong can that heavily affect on the trajectory of the object.
Being able to create this game as well as solve the problems really showed how important collaboration is in any work and especially in physics. Just like different quantities describing motion, everyone has their own way of helping and contributing to the study.
We hope you learned something new from our game-based physics experiment, Good Froyo, Great Froyo, which enlightened you with concepts applied in physics for fun and entertainment. Thank you for watching!